Okay, so we talked about mixtures and compounds and pure elements yesterday. Uh, Today we're going to talk about physical and chemical properties, starting with the phases of matter that we look at. So in chemistry, we only have gas, liquid, solid. So there is no plasma. We've discussed this in class that plasma is just a superheated gas. So in chemistry, we just call gas, liquid, and solid. So solids are tightly packed. They cannot be compressed. They are as compressed as can be. So they have a definite shape and a definite volume and have the least amount of kinetic energy out of all of the phases. So in your phase diagram, you have a lot of energy, but it is all potential energy. There is no kinetic energy really going on in the desk that you're sitting at, or the if you're watching this at home on the couch you're laying on. It is only vibrating against one another. So liquids are less packed. They don't have a definite shape, but they have a definite volume. Uh, they have more kinetic energy. Of course, you see that a liquid can move around. So if you have a water glass, you can move it back and forth, but it will take the volume, it will take the shape of whatever it is inside of. You are able to compress it, otherwise you wouldn't be able to have a pressure washer type thing. But it is less compressible than what gas is. This is why we don't use liquid in tires. You could use liquid in tires, but it wouldn't be nearly the kind of pressure that a gas can give. So gases are very compressible, like we've talked about. There's compressed air that you put into your tires when you drive. You have compressed air for like nitric oxide at your dentist. It has an indefinite shape and volume. It will take the volume of whatever the amount of compressed air is in a cylinder or in the room. Uh, it has a ton of kinetic energy because it will go back and forth, back and forth. We go over gas laws later about how pressure and temperature and volume all connect together to describe what a gas does. So we talked about inorganic and organic. Remember, if it is organic, it contains a carbon and a hydrogen atom. If it is inorganic, it will not contain both of them. It can contain one, but it won't contain both. So physical properties. Physical properties can be observed. They are description and appearance. So we talked about quantitative and qualitative. So in your lab this week, we discussed a lot about physical properties, not really the chemical properties, only the potential chemical properties of an object. So examples are your mass, length, volume, density, viscosity, uh, magnetism, your luster and ductility, conductivity, malleability, color, boiling point, melting point. They change in a physical state. So from gas to liquid, from liquid to gas, from liquid to solid, from solid to gas. All of these are physical property. Luster, talking about metals, whether it is bright or not. Uh, Conductivity, whether it can work with electricity or heat. Viscosity, whether it is a substance that is a solid or a solid liquid type thing. So like honey would be a viscosity thing, and mass, length, volume, density, all things that you're used to. So chemical properties are your other. So when we describe matter, we describe with chemical and physical. So chemical, of course, means that you are looking at the description of how a substance undergoes a chemical change. So how soluble it is, how flammable it is, how reactive it is, how it fails to react with certain things. So brought in contact with another substance. So the examples are nitric acid reacts with copper to produce a red-bound gas. Uh, if you look at iron, it oxidizes when it comes in contact with water on a longer scale and turns red. That is a chemical property. When water can be decomposed into hydrogen and oxygen gases with electricity. So Going through, I'll put in a question in your Edpuzzle for you to look at each one of these and describe them. All right. So describe these five. Are they chemical or physical property? So are these a chemical or physical property? So for instance, wood is flammable. We talked about flammability is a chemical property. Ammonia is a gas at room temperature. If you're just stating it's a gas, then it's just a physical property. All right. So that is your part 2 of notes. Please let me know if you're having any problems. Good luck for the rest of your week.